liftoff on Apollo 11. Tower cleared.
We got a roll program. Houston, Apollo 11 is calling you on the high gain. How do you read, over?
Roger, loud and clear on the high gain.
Listen, Tranquility Base here. The Eagle has landed. It's one small step for man, one giant leap for mankind.
Welcome to this edition of NASA Images. I'm Lynn Bondurant. During this show, we're focusing on historic NASA documentary footage showing NASA technology spin-offs to medical and energy fields as well as others. Let's start off by going to a NASA report from 1979 about electric car tests.
This car, running on a dynamometer at NASA's Jet Propulsion Laboratory in Pasadena, is powered by a small electric motor and 20 batteries. It was designed and is owned by Wally Rappel, a senior engineer working on JPL's electric vehicle project. If large numbers of electric automobiles are needed in the future because of continuing oil shortages, engineers here and at other NASA facilities hope to be ready with the research answers that will make it possible.
I think the electric car probably will run, in terms of energy, just pure energy, about the same as a gasoline engine car. However, we're talking about energy displacement. The prime factor in favor of an electric car is that it can use any kind of energy to produce the electricity. Oil, coal, nuclear, even solar power, for example, can be used to produce the electricity which can then be stored in the car and used for power.
The assessment of current electric vehicles is being conducted by NASA for the U.S. Department of Energy. The research is expected to provide the focus and direction needed for future efforts. At a mile-long and infrequently used runway on the edge of the Mojave Desert, engineers prepare one of the electric cars for coast-down tests.
EV control to EV1.
Go ahead, control.
You ready to make a run? All right, stand by. On my mark. 3, 2, 1, mark.
Object of the coast-down test is to determine the electric vehicle's aerodynamic resistance. The test is performed by towing the electric-powered car up to about 60 miles an hour. At that speed, it's released. The tow vehicle is driven out of the way, and the electric car coasts to a stop. Both the velocity and distance are measured using a fifth wheel and recording device. This tells researchers the aerodynamic resistance and the rolling resistance of the car, both important factors in energy consumption. Another part of the program in the Mojave is the driving cycle test. The car is driven fast and slow, as if it were being driven in traffic. The car's energy flow is measured under this set of driving conditions, as well as the range that the car can achieve with fully charged batteries. Again, project manager Tom Barber.
The frequency of recharge depends very heavily on how the car is used, just as, for example, the gasoline mileage of your car varies depending on how you use it. If you use the car around town, you'll get probably 45 miles or so on a full charge. It takes approximately 8 to 12 hours to replace that full charge. On the open highway, for example, at 55 miles an hour, you might get as much as 75 miles, and the recharge time is still the same because you have to replenish the batteries.
Electric car research, an effort to find reasonable alternatives to gasoline-powered automobiles that may also be quieter and less polluting.
Not only was NASA involved with electric cars during the energy crisis, but also wind power. Later, during the next report, please notice that the blades of the large wind turbine machines are like wings in some ways.
Residents of this Rhode Island community can use steady ocean breezes to help air condition their homes in the summer or to heat them during the cold New England winters. They'll do it with a 200,000-watt wind turbine generator. The place is Block Island, about 35 miles south of Providence. This is the third experimental 200,000-watt wind machine in a 5-year wind energy program, a joint project of the Department of Energy and NASA. This New England island, like all windmill sites, was chosen because of its consistently high winds. The generator will electrify up to 250 homes during the winter. That's half the permanent residences on the island. Until the windmill, Block Island used all diesel generators for electricity. But now, wind energy and diesel fuel will work together to power the island. Block Island's winds should make it possible for the generator to operate at an average year-round output of 100,000 watts an hour.
Now, when we come to savings, it's directly proportional to the fuel. If this machine generates approximately 100 average, which it will, with 17-mile-an-hour wind, that would come to a considerable amount of fuel, 50,000 gallons, during the course of a year. And simply multiply that by the present price, and you can see that it's substantial.
Block Island is not the only community boasting a new wind generator. Another windmill now towers majestically 1,000 feet above the mountain town of Boone, North Carolina. And the folks from Boone have lots to brag about because their windmill is the largest in the world. The blades alone weigh 18 tons. They spread 200 feet from tip to tip, about the wingspan of a Boeing 747. The machine produces 2 million watts of electricity, or 10 times as much as the other generators. Before the dedication, engineers tested the windmill from the control van.
Okay, here we go. Monitor enable.
The electricity that's produced is cabled underground through the legs of the generator and then ties in here before it's sent down the mountain for distribution. Dedication Day was a big event in Boone. It was declared a town holiday, and everyone turned out to celebrate mountain style.
It's you on my pillow in all of my dreams. Another boy, they give the face to the ground, give the face to the ground, give the face to the ground. Another boy, they give the face to the ground, give the face to the ground. Another boy, they give the face to the ground.
Interest in wind energy is growing, and now that the cost of fossil fuel has increased and supplies have dwindled, engineers are once again turning to the wind as a potential source of renewable energy.
By September 1982, 2 more experimental wind-powered generators were being tested, as this 1982 report shows.
This is Medicine Bow, Wyoming, site of the dedication of 2 wind-powered generators on September 4th. The project is a joint endeavor of NASA's Lewis Research Center, the Department of Energy, and the Bureau of Reclamation. One unit was built by the Hamilton Standard Company and is nearly 400 feet high. It's capable of producing 4 megawatts of electricity. The second unit, constructed by the Boeing Engineering and Construction Company, is powered by a rotor 300 feet in diameter and can produce 2.5 megawatts of electricity. When operating together, the pair of wind turbines will provide enough energy to meet the needs of 3,000 homes in the Rocky Mountain area.
3 other 300-foot wind turbines were erected and successfully tested in the state of Washington. A third-generation wind turbine was installed and tested in Hawaii in 1987. Following successful completion of the NASA wind turbine development program, the machine was sold to Hawaiian Electric Renewable Systems Corporation in early 1988. According to Dr. David Spira of NASA, Hawaiian Electric is to operate the 3.2 megawatt machine to make commercial power, and the company is to give NASA and the Department of Energy 5 years of operation reports. Now let's move from wind power to a 1979 report called Satellite Freeze Warning.
Most of us take it for granted that there'll be fresh fruit in the stores all winter long. But citrus growers often have trouble getting oranges and grapefruits to our supermarkets during the cold season. In the past few years, fruit growers have spent millions of dollars trying to save their crops from winter freezes. These oil heaters are used for freeze protection. Crews can set them up early in the evening, and flames will warm the orange or grapefruit groves until morning. Many nights during the winter, Florida growers are faced with the decision whether to call out standby freeze protection crews at a cost of about $36,000 per hour, or to risk having crops ruined by an unexpected freeze. But now, NASA, the University of Florida, and NOAA, the National Oceanic and Atmospheric Administration, are developing a system to warn growers about freezing temperatures, using a computerized and more accurate means of forecasting the freeze line. Information from the GOES-1 weather satellite is received at the Ruskin National Weather Service Station just east of Tampa Bay and relayed around the state, alerting growers when and where to protect their groves.
We collect up to 3 hours of data from the key stations, and at 8 p.m. we enter that data into the computer. At that time, we will have our 8 p.m. satellite scene in the computer. It takes a few minutes to type the data in, and from that point on, it's very fast. The computer takes over and produces the map. So by about 8:30 in the evening, we can have our predicted maps for the rest of the evening.
Okay, Jim, here's the key station data for this hour.
Okay.
Soil temperatures, 55.3, 52.7, 51.3. Air temperatures, 55.2, 56.3, 57.8. Dew point is 35. This is the O2Z picture.
Yes.
Looks like we've got mid-40s in central Florida. Perhaps some near freezing temperatures in north central. Let's blow this area up at north central.
Okay.
Yes, that's the area. Yeah, it looks like there are some temperatures right at 32 up in north central Florida.
That correlates real closely with the reports we've received from growers.
Florida has certain cloud patterns that make it conducive to satellite weather predictions.
A normal severe freeze for Florida produces a very dry air mass over the state, which eliminates any cloud cover. And this is one thing that makes the system work well in Florida. When we have very, very cold temperatures, we do not have clouds obscuring the satellite data. It gives us a very clear picture of the state using the satellite scene.
Oil heaters, computers, and satellites, working together to help citrus growers bring an abundance of winter fruit to our supermarkets.
Next, let's see two 1981 reports which show how NASA's study of aerodynamics has spun off to trucks, freeways, and motorhomes.
NASA's role in studying things aerodynamic has ranged from several decades before the Second World War to the reusable space shuttle now being readied for its first flight. Using similar aerodynamic scaling techniques, NASA has been assisting in a Federal Highway Administration-sponsored project that may one day help engineers improve the design of tunnels and highways.
This facility is 110 feet long. The reason for that length is for the level section to be equivalent to about a half a mile long. So one could have about 5 sections of 3 tunnels and 2 no tunnels, about 500 feet long. And that gave us enough tunnels in a row such that we can observe the recirculation of the air from tunnel to tunnel as it gets dragged from one tunnel to the next by the movement of the cars, or actually backs up to go to an adjacent tunnel. We have 2 lanes of traffic such that we can have the traffic either going in the same direction or in opposing directions, just like would happen in a real highway.
Frequently, freeways and tunnels use up large areas of land that might better be used in other ways. The researchers are experimentally depressing and partially covering simulated freeways in an urban area to find out how much and how little tunnel is needed. One of the tests involves injecting trace gases that act like hot automobile exhausts. Coupled with carefully controlled wind and temperature measurements, airflow patterns can be determined that may help designers build more efficient highways and tunnels in the future. They come in a variety of sizes and shapes, from huge tractor trailers capable of hauling tons to weekend motorhomes used for pleasure by thousands. All share one common trait. They burn gasoline or diesel fuel to make them go. Engineers at NASA's Dryden Flight Research Center in California have been studying for several years how to help make these vehicles more fuel efficient. Aerospace engineer Ed Saltzman tells how.
We began with a vehicle that looked a little different than what this does here. We had square corners on the front and square corners on the back to represent the worst in vehicle design for high-volume haulers. And we documented the drag of that configuration. And then we began aerodynamic refinements, rounding the front corners, as you can see. And we smoothed the underbody so that the muffler and the axles are covered up in the transmission. And this reduced the drag, too. We compared that configuration with the original one. The most recent tests were run with the configuration you see now, where we have a partial boat tail. And we just compare the deceleration characteristics of each of these configurations and relate them back to the original one we started with.
For 6 decades, NASA has been studying aerodynamic problems associated with making airplanes faster and more fuel efficient. It was logical then that it could apply this same expertise to ground transportation vehicles. The results have been very encouraging. By rounding the corners and enclosing its underbody, this van has about 70% lower drag than before the modifications. The technique of reducing air resistance as the van travels along can be directly translated into fuel savings, about 30% fuel savings in this particular instance. The reshaped van is actually aerodynamically superior for its size to most sports cars on the road today. These successful aerodynamic tests are helping change the shape of vans, motorhomes, and trucks, making them more fuel efficient.
Another field which has benefited from NASA's spin-off is medicine. Our next report, which is from 1982, is about a space-age aid for coronary diagnosis.
In August 1981, as Voyager 2 made its way through the solar system from Jupiter to Saturn, beaming dramatic photographs back to Earth, researchers at NASA's Jet Propulsion Laboratory in California, using sophisticated image processing techniques, were busy enhancing significant areas of these images for scientific study. Today, the people at JPL, working in conjunction with scientists from the University of Southern California, are applying these same space-related computerized image analysis techniques to the earthly treatment of arteriosclerosis and stenosis of the arteries, diseases that affect thousands of Americans. Dr. Edwin S. Beckenbach, Deputy Manager of the Lyle Medical Program at JPL, explains.
The basic problem that we're looking at is an insufficient supply of blood to the heart. The blood that the heart pumps does not supply the heart. It's supplied by blood through the coronary arteries. Knowing how much of that blood flow is being cut off by this stenotic disease process, or this narrowing of the coronary arteries, is very important because if there's an insufficient amount of blood going to a part of the heart, the doctor has to do a bypass operation or some other kind of open heart surgery. That's a very risky procedure. It's not something you want to do unless you're sure you need to.
A special type of X-ray, called an angiogram, is made by injecting contrast dye into the diseased artery. This allows the computer operator, or physician, to locate the area of concern and indicate it to the computer by positioning the electronic cross accordingly. Once the computer has received this information, it can, in turn, supply the physician with what he needs to make an accurate diagnosis.
The degree of stenosis, or narrowing, in this particular vessel is such that, in general, a doctor provided with this image would have a hard time deciding whether the narrowing was sufficiently important to warrant bypass surgery or not. Two different doctors given this particular image might well differ in their opinion of the degree of narrowing by, 10 or 15%. And that difference is exactly the difference that becomes important when you're considering a serious operation like bypass surgery. The benefit of the computer is not so much that it is better than a doctor, but it is more consistent.
To calculate the degree of disease present, the computer first indicates the edges of the artery with black lines. The white lines, which just appeared, are the computer's best estimate of where the walls of the artery would be if there were no disease present. Using these as guidelines, statistics, such as the degree of narrowing, can be computed and printed out for the patient's file. The importance of the individual seated at the control panel of the medical image processing station, be it a JPL researcher now or a physician in the near future, should not be overlooked.
One thing we've really found out in this whole program is that if you take the individual, the human, out of the loop totally and try to automate the whole procedure using the computer, you are almost certainly doomed to failure. So to have the operator in the picture, to provide the computer with a beginning point, to take care of mistakes that the computer makes, and to finally decide whether the job that the computer's done is adequate is vitally important.
The Medical Image Processing Station, using space-gained expertise to extend the frontiers of medical science.
Our last videotape segment was really produced for a convention display, but we thought you would find it interesting. It deals with ferrofluids, which are magnetic liquids. Early use of the ferrofluids was intended for rocket fuels, but the ferrofluids have found other uses in other fields.
We needed a magnetic liquid for control of spacecraft liquid propellants under zero-gravity conditions in space. Now we have ferrofluid. Use your imagination. Ferrofluid is a liquid in which submicroscopic particles of iron oxide are permanently suspended. In other words, a fuel with magnetic properties. The technology we developed to solve our fuel problems in space is now being used to entertain you with higher quality audio reproduction every day. Ferrofluid research led to development of fuels that are controllable in the weightlessness of space. This eliminates a problem in space vehicles called chugging. This chugging effect is from lack of fuel or even flow of fuel through the engine. As a result, the commercial applications of ferrofluid are providing a wide variety of new products for consumer use and some major improvements in old-time favorites. Ferrofluid serves as an excellent heat transfer medium for cooling the voice coil in a speaker, so the system's ability to handle higher power is increased and speaker failure is decreased. For the manufacturer, the bottom line is better quality, fewer returns or defects, and lower manufacturing costs. Dr. Ronald Moskowitz and Dr. Ronald Rosenweig had been working on the development of magnetic fluid, and with the cooperation of NASA's Technology Utilization Services Department, they obtained a license to use the technology that NASA Lewis Research Center had developed. Putting all this together, they founded Ferrofluidics Corporation and have successfully advanced and applied the technology for a wide range of commercial uses. Applications have ranged from integrated circuit production, visual displays, analytical instrumentation, automated machine tools, and industrial processes. From us to you, working for you and with you. The technology is here from which your ideas can grow. Let's work together. Call the Technology Utilization Office nearest you for more information.
If you would like to contact NASA about spin-offs, please watch the credits at the end of the show on where to write or call. That's all we have for this edition of NASA Images. But before we go, let me remind you that you're cordially invited to see the displays at the Visitor Center here at the NASA Lewis Research Center. We're located near the Hopkins International Airport in Cleveland. Admission is free. Until next time, this is Lynn Bondurant saying goodbye.